Hi, my name is Herman.
My name is Mechatronic Project this project.
Hi, my name is Sahurin. I will be in charge in editing video for this project.
The Raspberry Pi is a low-cost credit card-sized computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people to explore computing and to learn how to program in language like Scratch and Python. It's capable of doing everything a stock computer can do, from browsing the internet and playing high-definition video, to making spreadsheets, word processing and playing games. It also has the ability to integrate with electronics projects as it can control LEDs and AC devices. One powerful feature of the Raspberry Pi is the row of GPIO, general purpose input and output, pins along the edge of the board next to the yellow video out socket. These pins are physical interface between the Pi and the outside world. Python is a widely used high-level programming language for general-purpose programming. Python is a wonderful and powerful programming language that's easy to use, easy to read and write. And with Raspberry Pi, we can connect our project to the real world.
Four pneumatic cylinders are utilized as a part of this project. The actuator utilizes the force of compacted air to create a force in a linear motion. The cylinder is moved when the potential energy that has been stored due to the compressed air is converted to kinetic energy. The sensor provided for this project was the NPN proximity sensor. Proximity sensor is a sensor that can recognize the presence of any adjacent metallic material with no physical contact. The PLC is used to supply the 24-volt current to the driver board. The switches are used to start and stop the process. A conveyor is used to transport a container that is filled with balls. Relays use electromagnet principles to operate a switching mechanism mechanically. The motor is connected to right relay for switching on or off and to left relay for changing rotation direction. The conveyor is actuated by an AC induction electric motor which is controlled by two relays. The cable and the adapter is used to connect the driver board to the COM of PLC. The driver board is used to connect the relay and the solenoid to Raspberry Pi. A box is designed and fabricated to store 8 balls while traveling on the conveyor belt. A few metal plates are added on the protruding part on the top of the container so that the container can be detected by the proximity sensor. The position of the protruding part is adjusted so that it can be detected by the proximity sensor when the container is under the feeder.
We programmed the system to make all 4 cylinders perform their outstroke at the very beginning by using Raspberry Pi. When switch A is pressed, the system is started. The conveyor will stop moving when the first proximity sensor detects the box. At this time, the 2 cylinders will perform their mechanical motion to allow the dropping of balls from the first feeder. Our system is designed to be fed out 2 balls at a time. After that, the conveyor belt will continue moving the box to the second feeder. Again, the conveyor belt will stop when the box is detected by the second sensor. Balls feeding process is carried out. After that, the direction of the conveyor belt is reversed to send the box back to the first feeder. The cycle is repeated until all the 8 balls drop. After that, the direction of the conveyor belt is reversed to send the box back to the first feeder. The cycle is repeated until all the 8 balls drop.
Firstly, the upper cylinder retracts and one ball drop to the space between the two cylinders. Then the upper cylinder will extend and followed by the retraction of the bottom cylinder to drop the ball into the container. Lastly, the bottom cylinder will extend and the cycle is repeated in order to drop 2 balls in each feeder.
Through the wastelands, through the highways, till my shadow turns to sun rays, and on we'll go. Through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around.
To add the GPIO library to a Python sketch, firstly the code needed for GPIO control and for the sleep function is imported. The 4th line of the code is used to clean up all the ports have used. It resets any ports used in the program back to input mode. This prevents damage from, for instance, a situation where a port is set high as an output but accidentally connected to GND, low, which would short-circuit the port and possibly fry it. Next, the GPIO port of every equipment including sensors, switches, cylinder and relays is renamed from GPIO pin number to short form of name of the equipment used to ease the user to understand the coding below. Then, the type of numbering system used for the pin is declared. In here, the numbering of GPIO used is Broadcom GPIO numbers, BCM. Every channel that are using is set up as an input or an output based on their function, so that the inputs can be read and control the output of the system. 2 switches and 2 sensors is set up as an input in this system. The outputs of the system are 4 linear actuators, which is the double-acting cylinders, and 2 relays, which is used to control the movement of the conveyor belt. Once the module is run, the 4-cylinder is programmed to perform outstroke to let the user to insert the ping-pong ball into the feeder. An infinite loop consisting of the indented code below is created. The if statement is used for conditional execution. The red NPN switch button, which known as switch B, is set and act as a stopping switch or can act as an emergency brake control switch. When switch B is pressed, Raspberry Pi receive the input of switch B as false, then the output of relays are controlled such as the conveyor belt will be stopped. The nearest enclosing loop is also terminated by the break statement, skipping the optional else clause. The statement of system stop is printed out to let the user know the status of the system. The black NPN switch button, which also known as switch A, is set to switch on the system at the beginning after the module is run if the switch is pressed and the input received is false. Firstly, after the system received the false input from switch A, the relay output is controlled such as the conveyor belt will start operating and move to the right direction, as the container will be placed at the left end of the conveyor before the module is run. After switch P is switched on, any sensors is triggered by any object below it. The ball dropping action to meet our main objective will be performed. The status of the system will be printed out for every stage of the system to update the user. When the left sensor, SSL, is triggered and the input received from SSL is false, the conveyor belt that controlled by the output of relays will be stopped. The upper left cylinder, C1, will first in-stroke then out-stroke to drop only one ball into the space between two cylinders. Next, the lower left cylinder, C2, will also perform the same process as C1 to drop the ball from the feeder into the container. The action is repeated once again in order to drop two balls from the left feeder into the container. After the action is done, the statement of done and conveyor continue to move in right direction will be printed out and the relays will control the conveyor belt to continue the rightward motion to continue the system. When the container reached below the second feeder, the right sensor will be triggered by the presence of the container. Then the same process as in left feeder is repeated in right feeder. After finish drop two ball into the container, the conveyor belt is programmed such that its direction is changed to leftward motion to meet with the left sensor and repeat the cycle until the container contain 8 balls. Another 2 balls will dropped from left feeder, then the conveyor belt will change its direction to rightward direction. The container will be meet with the right sensor once again and last 2 balls will be received by the container from the right feeder.